All right, so for number 12, um, we are looking at kind of a weird one. There's this big square root, and what's this absolute value sign doing? So let's start on the square root side. Now, one plus sign, one minus sign, neither of those are trig identities. I talked about in class today. One minus sine x is not cosine x because um, this is not a Pythagorean identity. So what do we need to do? Well, you really need to use the right side as a hint here. Because we're going to keep 1 plus sine x on the right side and it's not under a square root anymore, when you're going to multiply by a conjugate, because that's kind of what we do when we have a fraction and it's in terms of sine or cosine and there's nothing else to do, you want to pick the right conjugate. So I want to multiply 1 plus sine x over 1 minus sine x. I want to multiply that by 1 plus sine x over 1 plus sine x. So I picked the conjugate of the denominator because I'm trying to get a 1 minus sine squared under here to get a cosine squared. And this will create a 1 plus sine x quantity squared up here. And that will allow me to square root. So what am I talking about here? So remember, we don't usually FOIL the non-conjugates. They are the same thing, though. So I'm going to write 1 plus sine x squared. And then we actually do FOIL the conjugates. So 1 minus sine squared x. Okay, now you're square rooting a fraction. Remember, that means you can square root the top and the bottom. So the square root of 1 plus sine squared is 1 plus sine x. Now, what about this denominator? Well, it's still under a square root. I can rewrite 1 minus sine squared as cosine squared x. And the square root of cosine squared is cosine x. Now, what's up with the absolute value symbol? So you want to put that in because, well, the problem has it. But why is there an absolute value symbol? It's been a long time, but we talked about this a while ago where the square root of x squared is not just x, it's actually the absolute value of x. Because when you plug in, say, -3 for x, you don't get -3. You get the square root of 9, which is +3. So you don't get -3 back out, you get +3. And that would be true for any negative. So there's an absolute value around cosine x because sometimes cosine x is negative, but we want to make sure that it remains positive. Another reason for that, the square root of something should always give me a positive answer if the square root's built in, and so I need to make sure that's positive. The reason there's not one around 1 plus sine is because that graph, think about that graph, that's been shifted up 1. So normally the sine graph does one of these, but if we shift it up 1, the sine graph would always be positive. So you don't need to prove it. You're not going to be responsible for putting absolute values around on your own, but that is why that's there. Okay, number 13. So first thing I want to get rid of is this cofunction identity. So let's make this sine x, and the cofunction of cosecant is secant x. And that makes the problem nice and easy. I'm going to change secant to 1 over cosine. Sine over cosine is tangent. It's fine with me if you go right from this step. I would want to see this step for sure, and I would want to see sine over cosine, and then obviously you finish. Whether you show this second step or not is up to you. Okay, number 14, get rid of this cofunction. So secant squared x minus the cofunction of cotangent is tangent, so this is going to be tangent squared x. And that is equal to 1. This is one of the rearranged Pythagorean identities. So when you're filling out your sheet on Monday, make sure that you have all the rearranged versions so that you can use that on Wednesday. This one has a bunch of terms on the left side. Specifically, there are 4 terms. So this should indicate factor by grouping. Okay, so factor by grouping. Out of the first 2 terms, I can factor out a 2 secant squared x. And what would that leave me with? So from the first term, that would leave me with 1 minus, from the second term, sine squared. What can you factor out of the second group? Just a minus 1 to make sine squared x plus cosine squared x. Now, in our factoring days, we would say, oh, factor by grouping didn't work. I didn't get the same parentheses. But with trig proofs, remember, every time you factor, you can do a quick check for Pythagorean identities. If trig functions are being squared, you should always go look at the identities. So 2 times secant squared. You could also, if you want to take care of secant squared, make it 2 over cosine squared x, if that helps you. 1 minus sine squared x is cosine squared x. Minus 1 times sine squared plus cosine squared is 1. 2 over cosine squared times cosine squared, those cosine squareds cancel. 2 minus 1 is 1. For the next one, I see a fraction that I can use Hart method on. Anytime you have multiple terms added or subtracted in the top and one single term on the bottom, the Hart method is usually the easiest way to go. So what that means is 1 over secant x plus cosecant x over secant x minus cotangent x. Because the right side is supposed to get all the way down to just cosine, change everything to sines and cosines. What is 1 over secant? Cosine. What's cosecant over secant? So let's see, that's 1 over sine over 1 over cosine minus cotangent is cosine over sine. Take care of this ugly complex fraction here. Cosine x plus, so you would say 1 over sine times cosine over 1. So that's cosine x over sine minus cosine x over sine. So this term cancels with this one, and we are, in fact, left with cosine x. Now, 17 is not a Hart method because there's no addition or subtraction in here. So it's not this. That would be wrong. You do have to be careful of that. Instead, take a look at what you have here. Cotangent times tangent, those are reciprocals of each other, right? So I don't often use 1 over tangent or 1 over cotangent, but I do want to recognize that, yeah, those cancel each other out, right? 1 over tangent x, say I switch that one, times tangent x over sine. These cancel out, so it's 1 over sine, and that's equal to cosecant. All right. Now, we had something like 18 on yesterday's homework on, well, 2 days ago, I guess, on the practice 5.1 and 5.2. I believe this was number 8. So here you are again with another version. So take a look at this one and see if you kind of remember what we did. Remember, there are only so many unique proofs I can give you. You're going to see a lot of the same types of problems and processes repeated in all of these trig functions. All right, so what did we do with this problem? If it helps you, you can change to sines and cosines for this first part, but we multiplied cosecant times cosecant. This should say cosecant x, by the way, that's a typo. So cosecant x times cosecant x is cosecant squared x. Remember, cosecant is 1 over sine x, by the way. So 1 over sine x times sine x is going to be minus 1. So cosecant squared minus 1 minus cosine x over sine x. Be very careful here. Minus negative plus sine x over sine x. So that's going to be 1. Plus cotangent. You can make that cosine x over sine x if you want. Look for things to cancel. Minus 1 plus 1 minus cotangent plus cotangent. We're supposed to be just left with cosecant squared x, and we are. Just like in number 8 on the second worksheet we did, all of the work is done in that first step. So really it's like a 2-step proof. You're just showing a lot of steps in that first one. Okay, number 19, I see exponents higher than 2. That indicates I should be factoring. So something to the fourth minus something to the fourth is a difference of squares. So secant squared x minus tangent squared x times secant squared x plus tangent squared x. We're supposed to be getting 1 plus 2 tangent squared x. One of these is a trig identity. What's the one we have on our sheet? Tangent squared plus 1 equals secant squared. Maybe you have the rearranged versions on your sheet as well. If we get secant squared and tangent squared on the same side, 1 equals secant squared x minus tangent squared x. All right, so this is 1. And then how am I going to go from secant squared x plus tangent squared x to just 1 plus 2 tangent squared? So we've done this with sines and cosines before. Take what you want to get rid of. I want to get rid of secant squared. Replace it with its Pythagorean identity. So secant squared is equal to tangent squared plus 1. So I don't need this times 1 anymore. Secant squared is tangent squared x plus 1 plus this other tangent squared. And if I combine like terms, I get 2 tangent squared x plus 1. Oops, and I wrote it in the wrong order. I should switch it around. I'm not going to worry about that on a quiz. If you stop there, it's fine. Okay, number 20. Now be careful on 20. You can't do reverse heart method. That's an upside down heart. That's supposed to indicate that we cannot do that. You can do heart method on the first one. So this is good. We can do it on this side. You can't split up the addition or subtraction in the denominator because order of operations says you've got to do that before you can divide everything. You've got to do that addition or subtraction. But here, because every term is getting divided by just one thing, you are allowed to do it if it's in the numerator and you're just dividing by a monomial. You can check this with numbers too. Just make up any numbers and see which one works and which one doesn't. Okay, all that said, cosecant x over cotangent x plus 1 over cotangent x. All right, so now don't put them back together. You have a common denominator, but that would just be going backwards. So what do we do next? When we have a mixture of trig functions, we change them to sines and cosines. So 1 over sine x. Now cotangent is cosine over sine, so flip that. You're going to say times sine x over cosine x. 1 over cotangent is just tangent x, so that's going to be sine x over cosine x. Or again, 1 over cosine over sine, flip it, make it this. Okay, how does that help me? That gives me 1 over cosine x plus sine x over cosine x. All right, so that gives me 1 plus sine x all over cosine x. I've run into this fraction quite a few times now. What do I do here? I can multiply by the multiply by the conjugate. See if that gets me somewhere. Okay, so 1 minus sine squared on the top. Cosine x times 1 minus sine on the bottom. Remember, we don't usually distribute that through. This is cosine squared on the top. One set of cosines can cancel. Now, we've had this trick before. Forget if it was worksheet 1 or worksheet 2 or both. I have this. I don't want to go doing a conjugate again because I'm trying to get here. Now, what is cotangent? Cotangent is cosine over sine. What is cosecant? 1 over sine. And 1 is what? I have cosine. I have 1 minus sine in the bottom. I want to get on top cosine divided by sine. Remember, if you want something, if you want to have something that you have on the left side, if you want to get it on the right side, multiply it in. Multiply the top by 1 over sine. You're allowed to do that as long as you do the same exact thing to the bottom. You're multiplying by cosecant over cosecant, which is legal math. You're allowed to do that because you multiplied by 1. Cosine over sine is cotangent. 1 times 1 over sine is 1 over sine, which is cosecant. Minus sine times 1 over sine is minus 1. That's what we were supposed to get. So that's one of the trickiest problems, I think, because you have to multiply by a conjugate somewhere in the middle. You also have to do this little division trick. We're not used to doing that. We're used to doing this trick when we're trying to clear complex fractions, but you're almost like creating a complex fraction so that you can use your identities. All right, last two problems. So anytime I see powers higher than 2, I should be factoring. And this is a sum of two cubes. So let's make this sine x plus cosine x. And then the rest of the cubes formula is sine squared x minus sine x cosine x plus cosine squared x. All of this is over sine x plus cosine x. We've had a few problems where we factor cubes, so this has almost always happened. Not even almost always, this has always happened. One of these factors cancels with the bottom, so that's great. Sine squared x minus sine x cosine x plus cosine squared x. We've had this a few times too. Remember, sine squared x plus cosine squared x, because you're allowed to rearrange terms, they don't have to be right next to each other. You're allowed to say that that adds up to 1, and then we still just have the minus sine x cosine x. Again, the reason you're allowed to do that is, I think I did this in class. If I say add up these three numbers, you could say 1 plus 2 is 3, 3 plus 3 is 6. Or you could say 1 plus 3 is 4, 4 plus 2 is 6. I still get the correct answer in the end. I just added the terms in a different order. Okay. Last problem. Sorry, that one's finished. Last problem. Do this in green so it doesn't all merge together. Again, cubes. So factor with cubes. Tangent x minus 1 times tangent squared x plus tangent x plus 1 all over tangent x minus 1. Same thing I said for 21. Tangent x minus 1 cancels. Tangent squared x plus tangent x plus 1. Same rule using Pythagorean identities. Tangent squared x plus 1 is allowed to get replaced with secant squared x plus tangent x, which is what we were trying to prove. All right. Trig proofs take a lot of practice, right? So if you want more practice, if you're feeling iffy with these, go back to the first worksheet we had. So go back into our folder on Schoology and find the first worksheets, which was Trig Proofs 1, right? There's a blank copy on Schoology. Print it out or do it on paper. Try these again. You have not memorized every step for all of these, but now that you've done all of these packets, if you try them again, hopefully you're going to be like, oh, we just did that problem on packet 3, or oh, I remember this trick, or whatever. So these probably felt really difficult the first time around, and on worksheet 2 and on worksheet 3. The only thing you can do to improve is just keep practicing. All right. Also, make sure that you're studying your identities. Know these, rewrite these as many times as you need to. Print extra copies of this or just write it on paper, whatever. It's going to be in the same exact order, same exact spacing. Fill this out Monday.